Okay, today we're going to switch gears a little bit. We've been talking about rivers and that being fresh water. Well, today we're going to talk about groundwater. So your heading today is groundwater, and we're going to talk about things related to groundwater. Now, nothing to write, but I just wanted to kind of refresh about the water cycle. Water cannot be created or destroyed. The same water that was on Earth at the very beginning is the same water that is there now. It just changes form, it moves around. So let's say I have a puddle of water. It's going to evaporate, it's going to change to a gas. It's going to go up in the atmosphere. It's going to cool, condense, and fall as rain. Maybe that rain soaks into the ground, into the groundwater. Maybe it goes into a creek, which goes into a river, which goes into the ocean. It sits there for a while. Maybe it freezes for a number of years. But it's going to constantly be changing form. Maybe we drink it and we pass it out, and then it evaporates and it's back into the atmosphere. The water cycle, you can't create water, you can't destroy water. It just changes form. So the water that comes out of the drinking fountain today could be the same water that your great-grandparents' dog drank at one point. Could be, okay? It's just going to change form. Write this down. What is groundwater? Groundwater is found underground in the spaces between rocks, sand, and gravel. It may be 1 foot to hundreds of feet below the surface. So, you got rocks and gravel and dirt underground. Basically, groundwater is going to fill in all those spaces. If I filled a cup full of rocks, I could dump water in there and it would fill in the spaces between those rocks. I could then put a straw into that cup in between those rocks and I could drink that water. I could suck it out. Okay, that's kind of what groundwater is and digging wells. In some places, it is just below the surface a foot or two. Other places, you have to dig hundreds of feet to get to groundwater. I was putting in a septic tank next to my shed. I put up a shed, and we couldn't put in a septic tank because the groundwater levels were too high. They dug a hole 6 feet down, and the hole was half full of water, and it just stayed full of water there. So the groundwater levels were too high to dig. I remember one time when I was a kid, we were putting pasture fence in for our cows, and was digging a hole to put in a new post, and all of a sudden dug one more shovelful, or one more of the post digger scoopfuls up. I pulled it up, and the post hole filled with water. The groundwater was just below the surface there, and we had hit it. So groundwater. You don't need to write anything, but groundwater is constantly moving in the spaces between the rocks. So if these are rocks, the little spaces there are full of water. The Big Sioux Aquifer is an aquifer that we use to suck up water. Little map there. I would write both of these bullets here. I'm not sure when my picture's upside down. But go ahead and write down springs feed some lakes with water where the groundwater has an opening to the surface. Wells can extract water from aquifers for drinking. I'm not sure, but I believe Brant Lake is fed by a spring, which basically means the groundwater is close to the surface and it started bubbling up and helps fill in the lake. I believe the Mississippi River in northern Minnesota is the same thing. There's a small lake at the very beginning of the Mississippi River, and it's filled by a spring that starts the river, basically. And it starts really small, and then other creeks and small rivers dump into it, and it gets bigger and bigger. If I'm going too fast, you can pause. So you don't need to write this. But how do wells work? Basically, think of that cup of rocks that you dumped water in between. And you're going to drill a hole into the aquifer. You're going to insert a pipe, and you're going to put a filter on it so the pipe doesn't clog. So if you wanted to break that down really easily, you had that cup full of rocks that you put water in, stick a straw in there, okay? And that straw, then you would suck on the straw, and that would act as you pumping water up. So kind of similar. Artesian wells or natural wells. Don't worry too much about that. Go ahead and write this down. We're almost done. Recharging wells. Wells can go dry if water is used faster than it's replaced. Wells are recharged by rain and snow melt. So you can use up all of your water, all of the groundwater. The groundwater levels are pretty low in the Midwest. If you pump it out faster than it can recharge. The way it recharges is we get rain, and that rain soaks into the groundwater and kind of fills it up. The only thing is it takes a long time for groundwater to recharge. So a couple years ago, we had really wet years that probably helped the groundwater some. This past year was drier. We probably depleted some of our groundwater then. So let's write this down. Go ahead and write this down. How much do we depend on groundwater? 99% of rural drinking water is groundwater. 51% of all drinking water is groundwater. Rural, we're talking about farm, small communities like us. This school gets its groundwater, or gets its water from a well, from groundwater. So you wash your hands, you drink from the drinking fountain, you use the bathroom, all of those, that's all getting pumped from the ground. Let's stop there.